uh, Joanna. Thank you also to Abbas and Paul and others for having me here. I'm in the session on big data. I think now realizing what I'm going to talk, I could be in any of the earlier sessions or so, but I think it's a good timing to have my talk now. And I chose as title, What Makes Dementia Research So Difficult? A few methodological considerations. And as I was preparing this slide, I've been working in the dementia field for, I think, close to 15 years. And it was good to see Bert here because I started under his tutelage. And then Monique got a PhD under her supervision. And also Suda, I consider her as a mentor with all the collaborations we had at Framingham and now in Texas. So also for me, a kind of a journey through time and seeing all my heroes present there. And here I am to talk about methodological considerations. And when preparing this, I actually started feeling sad because I kept on thinking about more and more limitations and issues that I've encountered in 10, 15 years of dementia. But I'm actually reassured because many of those, and I won't be exhaustive at all, I'll just pinpoint 2, 3, or 4 of these, have been discussed here. So they'll circle back in a different way. Now, don't expect me to provide solutions. Like Bert said, epidemiologists are good to study the intact human. I think epidemiologists are very good at pinpointing the problem. And then it is up to the field to find a solution. So I'll be pinpointing some problems here, and perhaps we can have the discussion afterwards. Now, just as a brief introduction of myself, I work at the Erasmus Medical Centre, also have an affiliation with Harvard. And for those of you interested, half of my time I spend at the Dutch funder. ZonMA is the Dutch MRC, and NWO is the UK DRI. I'm a board member of both. But today it's going to be on subject matter. I think that the slides should work. So I'll just start with a few considerations. And really, I think we've heard many of these here already, that dementia is a multifactorial disease with various pathologies, and field is struggling with how exactly to define this disease process. Average age of onset is around 80, at least in the data we use in Rotterdam. Sudha mentioned 85. So it's really is a late life disease. It may be the disease with the highest average age of onset. So it's kind of almost the ultimate outcome before death. And it has a long preclinical phase. I remember Monique's slide with that green phase transitioning into orange and then red. Monique, I've been using that slide as well, perhaps without you knowing, but it is a fantastic slide. And notwithstanding all the talk about biomarkers and ligands and imaging, it still remains inaccessible. You still cannot really take a brain biopsy. Now, if you would translate some of these issues, and it comes back into the issue of competing risk. We've heard a bit about that in the Mendelian randomization discussions. We also heard about reverse causality and accounting for multiple component causes. And these are the issues that we need to address, need to recognize. And my talk will be about showing a few more examples, like what is exactly the issue. I think many of you can appreciate what these are, but also understanding that perhaps not all of you have an epidemiological background. I'll just try to, qualitatively explain some of these issues, and that perhaps will also answer the question, like, what can epidemiologists mean for your research? I think we are the subject matter expert when it comes to applying methods and research in real world data. So and all the difficulty and quote unquote mess that's out there in an uncontrolled non-laboratory setting. That's, I think, where epidemiologists come to the fore and can really help you in at least identifying what may be the issues. So I'll just start off with this slide, and it circles back to the first session on multimorbidity. And basically, these data are showing for men and women separately the lifetime risk of any of these major 6 diseases starting from age 45 years. So basically, we just said, okay, of all people who are 45 years of age and are free of any of these diseases, how does the lifetime cumulative incidence, how does a lifetime risk develop over the course of the next decades. And what you see obviously is that in total, it goes to around 95%. And it makes sense because eventually you have to die of something. But the more interesting thing is that if you look at these colors, that's where you see divergence already between men and women. For instance, the brown one is chronic respiratory disease. It's much more in men than in women. And conversely, for instance, neurodegenerative diseases, of which the largest component is obviously dementia, is much more incident in women than is men. And obviously you can then start deliberating about whether this is causal or not, or whether other things are happening here. And that's basically what I want to touch upon here further. Now, here basically we collapsed men and women together again, but we made a different stratification. Was just look at the lifetime risk of any disease. So note here what you're seeing here is basically the outer edge of this curve here. And in this case, what we did is calculate the outer edge for people that had none of the three risk factors, in this case, smoking, hypertension, and overweight, to people that actually had all three. And you could really see the gap. Again, eventually everyone dies, even if you do, but there's a gap of on average 11 years. So basically, if you are healthy, you'll have 11 more years in health. In this case, not having one of those 6 non-communicable diseases. Now, so far so good, but what you will see next, and if we then look at these two groups and then look at the various diseases, that's where this issue of competing risks start emerging. Because what you will notice here is comparing people without the risk factors to those that have all 3 risk factors. Obviously, you will see that if you do not smoke, etc., you won't have a chronic respiratory disease. You'll have less diabetes. Obviously, that's the obesity connection, less heart disease, less stroke. But especially here with neurodegenerative disease, that's where you see things happening. And that's obviously because of the competing risk, that if you are healthy and you don't die of something else, you have to die of something eventually. And in this case, that's dementia. And that circles back to some of the earlier discussion we had, like how to deal with competing risk. Now, again, as I said, I'm not going to provide answers how to deal with it, but just take you along the way how epidemiologists would look at such issues, because everyone understands this competing risk qualitatively. Now, as epidemiologists, we would start going into the causal inference direction. And this is a nice paper where we basically said, especially in the realm of dementia, considering questions before methods in dementia research with competing events and causal goals, really arguing that before we even touch our data set, we really need to first get our research question as accurate as possible. And again, it doesn't hold for population research or for epidemiologists. It basically holds for all research we do. Get the specific research question correct. Now, I've drawn it here. Basically, if you would look at smoking and the risk of dementia, obviously we know that if you smoke, you will also die. And 19 and 20 is just indicating that there's a chance that you would die earlier because of smoking, let's say at a follow-up time of 19 years. And only after 20 years, you could or would or should have developed dementia. But now you're not observing that. And this is just a diagram showing it. There are multiple ways of looking at it. And basically now the research question will become very important, because there's a difference in asking this first question, namely, if I would, and in this case, we're not looking at smokers and non-smokers. If you're talking about causal questions and intervenable questions, we're here talking about smoking cessation and continuing smoking. So first question is, what is the risk of smoking cessation compared to continued smoking over the next 20 years? Versus a question, what is the risk comparing smoking cessation to continuing smoking, given that you will survive 20 years? Now, there's a difference in those two questions, very subtle. It's the part, given that you will survive 20 years. Now, at times, know whether someone will survive 20 years, especially as a patient. They don't want you to tell them, like, if you survive 20 years, then you will get dementia. They're not interested in, they're like, I'm happy if I can survive 20 years, right? So the question you're asking really will impact how you then analyze your data. So the first question is very relevant when it comes to risk prediction. Like, the patient is sitting in front of me, what will happen to this patient in the next years? And part of that future could be that that person dies and therefore does not develop dementia. The second question is, what is the risk of dementia given, or let's say forcing everyone to survive? That becomes the causal etiological question that we as academics are perhaps much more interested in. So note here the difference in these questions. And really, if you go further, and this was just the first, was comparing this first question to the second question. And this one, the question is the question that the patient is interested in. And what you'll notice here, it's a very subtle difference, but we estimated a total effect that's basically irrespective of what happens in between. Just looking at smoking and dementia, we estimated a total effect of smoking cessation on 20-year dementia risk of 2.1. These are risk differences. So basically, if you just look at it from this perspective, it means that stopping smoking will increase your risk of dementia. And that's because it precludes you dying from lung cancer. So it's a good thing. Whereas if you would say the controlled direct effect of smoking cessation, had that been prevented, that's protective. And that's basically what we as academics would be interested in, etiologically speaking. And there's not a right or a wrong question. Both questions are valid. Both questions can be rightfully asked and are asked. So there's no use in discussing and to pick sides here. We just need to realize, what is our interest? Are we here as clinicians and trying to improve clinical practice, or are we here trying to unravel the dementia disease process? And both aims are good. Now, we went further in asking some of these questions. And again, I won't take you through all those graphs. I'm just trying to depict the reasoning that epidemiologists have. So I'll go through it quickly. If you follow it, that's good. If you don't follow it, that's good as well. Just realize that this is how we work. This is a thesis, it's kind of a paper that's in press now in epidemiology, but if you already want to read it, if you look up this PhD thesis, it's already in that thesis there. And basically what we did here is look in the literature, and we found contrasting findings where, if you would, again, phenotypically just look at cancer and dementia, many people have suggested an inverse association. And there are a lot of hypotheses out there that it has to do with telomere length. If you have long telomeres, it predisposes to cancer, but maybe protective of dementia. If you have short telomeres, it might be vice versa. And there's a host of explanations out there. And one of those can also be just the fact that there are competing risks. So if you don't get cancer, you will get dementia, vice versa. It becomes very difficult how to disentangle that. And again, here, you as epidemiologists, we start thinking of, let's draw these DAGs, these causal diagrams, to identify what we want and what is the exact question. And very often from that reasoning, you move towards your solution automatically. And in this case, obviously, if you're looking at cancer and dementia, we assume that there is some biological entity indicated here as a P that will lead to dementia. This is just mentioned here to be complete, to showcase that we are adequately taking care of confounding. That's just a notation. But obviously, we don't know when the very first cell develops into a cancer cell. So that's something we cannot measure. So you complicate this graph further, and then you'd say, well, we don't know when the first cell occurs, but we do know when there are sufficient number of cells to give you clinical cancer. And in the end, we'll be associating clinical cancer to dementia. But there's a time lag between the first cancer cell and clinical cancer that in the meantime can lead to death, and that's what we call immortal time bias. Now, by drawing such DAGs, automatically the solutions start emerging, like, hey, if you adjust for L or do propensity weighting for death, you can start accounting for these complicating factors and try to deal with immortal time bias. Now, once you solve this, and you end up with a similar situation as in the previous slide, that people that have cancer may die before they go on to develop dementia. And in this case, as epidemiologists would say, that if I'm interested in this causal question, you need to condition on the fact that someone survives. Now, we would typically draw that with the box around the D, and then you get the collider, so you open up this path. And then the solution emerges that, hey, if you have opened up this path, you have to adjust for L2 to block it again. That's the way we reason as epidemiologists, trying to kind of abstract your clinical question, your etiological question in such DAGs, and hopefully through those DAGs identify how we can solve it. And sometimes the answer is we cannot solve it, but then at least you know what exactly you cannot solve, and that's something then to write up in your limitation section. And then you can complete the whole DAG like, hey, this is what we're looking at, and this is how we're going to analyze it. And in this exercise, what we did is really go from the full naive association towards the one that it's adjusted with weights for confounding and for sensing for death. And you really see here that if you kind of mirror what's out there in literature, you indeed see an inverse association between cancer and dementia, either whether it's in a risk difference scale or the risk ratio scale, or even at hazard ratio scale. And as you move towards more stringent control of several of those factors, and I'm not implicating that we have full control of those factors, but just seeing the effect estimate change tells you that something is happening. You actually even see a slightly increased risk, in this case, a shared risk between cancer and dementia, not so much an inverse association. And again, it doesn't say that this is the true answer. It tells you that, hey, we need to be much more careful in the exact question we're asking and then see how we can solve it. Now, if we move forward, a second issue that's perhaps not related to competing risks, but if you abstract it, you start seeing similarities, is this issue of reverse causality. And we already saw this. And it's already been mentioned that many of these factors that are mentioned here, you could argue, are these really causal risk factors, or given the fact that the disease process may be 10, 20 years before clinical diagnosis, that subclinical disease was already affecting some of these risk factors, that subclinical dementia or any related process leads to deterioration in the risk factor under study, and therefore the association of the risk factor with dementia. And technically speaking, it's an issue of confounding my preclinical disease. Here, actually, I noticed that an arrow from this Y all the way to here dropped off. That would complete the confounding diagram here. And then once you've identified that, you can start arguing, how can I adjust for that? And one typical way of doing that, what studies have done, including my own work actually in earlier years, was to say, okay, if I'm worried in the association of physical activity and dementia, that already at baseline people may have subclinical dementia affecting the physical activity level, let's exclude the first so many years of follow-up time and then only have the follow-up time start after that. And once you draw that, you see that you're actually building in immortal person time and thereby actually introducing selection bias. What I like about this way of reasoning is that you'll soon figure out that there is no single best study. Each study has its advantages and disadvantages, just like the toolbox I alluded to earlier. And sometimes for the same question, you need to use 2, 3, 4 tools and then synthesize the conclusions together to get a consensus. There's not going to be a single study that's going to give you the full answer or the whole answer. And then considering some of these lifestyle factors, whether or not they are causal, leads you to, all these trials. I think 1 or 2 have already been mentioned. Some find an association, others do not. And there are multiple explanations out there. And one thing that we explored more recently was going back again and asking the first question, who are the persons being enrolled in these trials? Are they actually the persons that will benefit most? Because very often we think like, oh, let's do a trial, and we start having a discussion of what is happening after the trial. But we actually ask the question, what happened before the trial? Was the trial needed? Was it done in the appropriate setting? And what we did here is basically look at 10 trials. They also show you 5 ongoing trials. And what we did is apply the eligibility criteria from those trials to the Rotterdam study, which is a population-based study, just to see what proportion of the general population would actually have been eligible to participate in this primary prevention trial. And what I'm showing you here is that comparing those that were eligible, and I think by and large the eligibility was like 35%, meaning that the majority of the population would actually not even qualify for these primary prevention trials. But even if you would look among eligibles, you would see that in all these trials, about more than 70% of these individuals, based on current cardiovascular guidelines, would already qualify for cardiovascular preventive treatment. So what use is it to then also have these participants in this trial if they already qualify for statin use and for antihypertensive use? So even if it turns out that having cardiovascular prevention is delaying dementia, was this the appropriate group? And even among ineligibles, you see that there's a substantial proportion already eligible for cardiovascular medication. If anything, it's a smaller proportion. So this may be actually an even more interesting group to analyze, study whether cardiovascular prevention would prevent dementia. And we did the same for ongoing trials. And basically, you see the same pattern here, that the majority of participants enrolled in primary prevention trials of dementia already qualify for primary prevention. So why are they enrolled in the trials? Like performing a COVID vaccination trial, asking the question, do these people benefit from COVID-19 vaccination, knowing that these people already benefit from it? It's, for me, a redundant question. Now, what we did next is basically compare eligible persons and ineligible persons, and then just ask the question, what is their, let's say, 10-year risk of coronary heart disease? And also ask the question, what is their remaining lifetime risk or 10-year risk of dementia? And what you see here that actually the 10-year risk of dementia in those people that are ineligible for the trials on average, if anything, is higher than the eligible persons. Again, putting forth the question, what are we trialing in which group, and does it even matter for this group? I think there's still some interesting data and knowledge to be gained from such trials, but I think starting off knowing this will put that into a better perspective, like what actually are we trialing here? And final point, I hope this talk is not too disjointed, but it's really a few methodological considerations, really to tease you and get you thinking, is already alluded to earlier, this whole definition of dementia and Alzheimer's disease. And, you know, having worked now for more than 10, perhaps even 15 years in this field, starting off as a naive, yes, I dare say naive, innocent, dare say that in these 15 years, I've really seen this almost power struggle of who will be able to monopolize the term Alzheimer's disease. I don't understand it, but it's still happening in front of my eyes. But let's just accept it and see what it tells you. And now there's this new framework, and there are new research guidelines coming out as well. I just want to point to a few issues that are mentioned here, like the term Alzheimer's disease will be applied if biomarker evidence of both A beta and pathologic tau is present. I would argue, well, there's amyloid present, don't call it Alzheimer's disease, call it amyloid disease and tau's disease and amyloid plus tau's disease. Why do you need that name Alzheimer, that tag Alzheimer? I think there are other considerations than scientific considerations there. And this framework does not depend on amyloid and tau being causal in AD pathogenesis. So for me, this really showcased that there's nothing scientific or pathologic people just want to claim that Alzheimer's disease because even if you admit it's not causal, but still we want to call it that, doesn't make sense to me from a puristic scientific point of view. And also here in that JAMA neurology paper, that we want to standardize language usage for research, clinical, and public health purposes. And I have trouble with trying to combine three totally different purposes into a single framework. I think that's already where the problem starts. If you want to have a framework for clinical management and it works for clinical management, it's absolutely fine. Keep on using it for clinical management. But it doesn't mean that that exact same framework will work for etiologic research. It doesn't. Perhaps it may, but that's something we need to elaborate further and discuss before we blindly say, well, if it's for research, clinical, and public health purposes. That's a bold claim. Now let's just see what's happening. So suppose dementia and amyloid are not causally related. Indeed, suppose they are not causally related because that's the room that the definition is allowing us. And we have here a risk factor for amyloid. And suppose we do a case control study, and as Bert Hofman said in the morning, the case control studies are the most difficult studies to design in epidemiology. And for me, it's always when I go to the AIC, I never see epidemiologists presenting posters or talks on case control studies. It's mostly the non-epidemiologists. So either we are missing the point here or something is going terribly wrong. But suppose you define your cases according to this definition, meaning that you'll be defining cases as people with dementia in the presence of amyloid. Now, unless you apply that same criterion to your controls, which never happens because you get your controls usually from the general population or normal controls, they're never conditioned on amyloid. And because they're not conditioned on amyloid, it means that whatever risk factor you found here will always be in your case control study associated with dementia. This is, again, a collider bias that you're introducing here because of the fact, not because you're including wrong cases, but because you're taught to the controls. You should listing those on the same condition, namely having amyloid. And conversely, suppose there's a vascular risk factor associated with dementia. Again, there's no causal link between amyloid and dementia, which the definition allows us. And if you would say vascular disease is a reason to exclude the diagnosis Alzheimer, if you do that, you're conditioning the other way around, then you will never find a vascular risk factor to be associated with what you call Alzheimer's disease because you forcefully excluded it and you don't use the same condition in your controls. If you would, you probably would find it there. And I think these are some issues, and this boils down to what we discussed earlier about the multifactorial nature of disease, and you need to appropriately account for that. Either in the discussion we had about interaction, you can use the X, you can use the component causes, as also suggested with Ken Rotzman, that there can be one disease can be caused by multiple causes, and I think now people are agreeing that that may be the case, but still, I think trying to monopolize the tag Alzheimer is kind of still hampering the field moving forward. So in conclusion and recommendation, first, I hope I didn't make you too downbeat about this field, so people new in this field don't feel deterred, but actually see this as a motivational talk. It poses complex methodological challenges, and I think it's a good thing that there are methodological challenges. And these are amplified. I'm not saying they're not present in the cancer field, in the diabetes field, but they're amplified here given the natural course in which many of the other systemic diseases are themselves risk factors for dementia, and the fact that it really is a late life disease where, for instance, competing risks are really amplified, and the long preclinical phase really gives it the issues of reverse causality. But again, if you look at all these issues separately, solutions are present or are being developed. I think that's a very good sign. No one said it's going to be easy, but it's not impossible. And I'm actually happy to see that there's work being done with methodologists and epidemiologists trying to tackle some of these issues. But in the end, I think we need to jointly address these challenges because, as I said, epidemiologists are very good at pinpointing the issues, but the solution is something that has to come from the field because it also needs subject matter knowledge on top of the methodological knowledge to provide those solutions. I think this was my last slide, so I thank you for your attention.
Thank you very much. Fascinating talk. Questions? I'll give it to Neil first.
Thank you for a lovely presentation. I wondered if you've got two studies. One study is very precise, but very likely biased. You have another study that's very likely imprecise, but is unbiased. Which study should you prefer? And does this have any implication for triangulation? I'm just thinking in the context of meta-analysis.
I would, in this situation, always go for the unbiased for two reasons. Because if you have a very precise study, but it is biased, what you're getting out of it is a very precise estimate of the amount of bias. In contrast, if you have a valid study, but it's imprecise, all you need to do is wait until there are multiple valid but imprecise studies, and you just need to meta-analyze those to get the precision you needed.
And the implications of that for triangulation with large observational studies that we think are probably flawed. We sort of wave our hands a bit and say, triangulation is great, all studies are great, we need evidence from everything. But if we know that there are studies which are flawed and likely biased, it doesn't matter how many additional studies we get, we're going to get more biased evidence, more precise evidence of the
Indeed. And that's my biggest concern, that there is this notion, and I think this session is called big data. There's this notion that big data will solve everything. All that big data does is improve your power. It does absolutely nothing on any issue related to bias. And power is separate, just a single issue. But in bias, you get confounding bias, selection bias, information bias, all those other things. And nowhere in the epidemiological literature you will see that increasing sample size is the solution for any of these biases. And for me, that's a danger that I think there's a lot of journal editors and almost the whole of the general public is staring blindly at, as if big data will solve everything.
Thanks, Arfan. I like very much your discussion on nomenclature and very clever point on the case control setting. But we always get this, comment back that epidemiology studies, you don't have Alzheimer, you're not sure about the diagnosis, it's all dementia. How do you address that?
How do I, with a sigh, that's the first way for me to address that. Well, look, I think in epidemiology, I don't consider epidemiology as a different field. As a start, it's a fundamental part of any research. So either all research is epidemiological or no research is epidemiological. But that's the type of research I do, which is population-based. I usually try to argue that, okay, deliberately we're looking at dementia, given the multifactorial nature of the disease, given that current biomarkers are incomplete and we don't explicitly want to relate anything to Alzheimer's disease. Usually, if I look at my own work, if we have looked at a subtype of Alzheimer's disease, however we could or could not define it, it's usually been because we were asked for that. I try to stick to dementia. Well, just like smoking, right? Just like lung cancer. Usually you just study lung cancer. You don't study smoking-induced lung cancer, right? Or cholesterol-induced heart attacks. Usually just heart attacks. So why would we look at amyloid-induced dementia, which is then called Alzheimer's?
So I was just going to come back on the big data. I mean, big data can be useful for bias because you can start stratifying, getting more, better matching within your cohort, whatever, propensity score, whatever it might be. I mean, it doesn't solve the problem, but it helps you deal with, can help you deal with bias.
Oh yeah, that point is absolutely well taken. It can help you deal with it because it won't give you empty cells if you start stratifying, which basically again tells you that it's helping you with the power in essence. But I think we both agree on the same thing here. Yes.
Thank you. Any other points? Okay, thank you very much.
Thank you.